Look at this one alright, let's take a look at this one real quickly. We set up our equilibrium chart. Now it's a matter of solving for it. They told us that the equilibrium constant for this reaction was 1.80. They want to know the equilibrium concentrations of each gas. So I'm going to shrink up my chart here. And I'm actually going to create a little square here to write on. Okay, got a sheet of paper. Alright, Kc equals x squared over 0.188 minus x equals 1.80. Well, right away we should see that the assumption is going to fail. We're going to have to gut through the quadratic equation. So it's going to be x squared equals 1.80 times 0.188 minus x. I'm going to distribute, and that's going to give me 1.8 times 0.188 equals 0.3384 minus 1.80. And that gives me x squared. I have to move everything to the same side of the equation. So I'm going to have to change signs here. So now I'm going to plug and chug into the quadratic formula. Opposite of b plus or minus square root of b squared minus 4ac, and since it's a negative, negative times a negative winds up being a positive, divided by 2. Since b is negative, we know we're going to use only positive results from there. So I get 1.80 squared plus 4 times 0.3384 equals square root of 4.5936 plus 1.80 negative divided by 2. So now I take the square root, and that gives me a square root of hope you're not seasick from that. Gives us a square root of negative 1.80 plus 2.143 divided by 2. So minus 1.8 equals, divide by 2 equals, and I get an x of something very different. I get an x of not shown. Alright, and here's where keeping everything in your calculator turns out to have been crucially important. Because I believe the answer key to this one actually does not have a right answer to it. I've done this a couple times now. Yeah, the answer key actually doesn't have a correct answer. They are off by a power of 10. because your x value is 0.1716. That's your x. And that's your concentration of these guys right there. That's not an option. What they say is the right answer is actually very close to that, but it's off by a power of 10 somewhere. They goofed. Not only that, but if you look for further evidence that they goofed and had things off by a power of 10, we solve for our other one, 1.88 minus 0.1716, and that gives you 0.01637 molars, which is actually what they have as that first answer and that what they label as the correct answer. Further evidence that they goofed is, remember, you can always double check yourself when working equilibrium concentrations by plugging your numbers back into that equilibrium constant. 0.1716 squared divided by 0.01637, I wrote my 3's and my 7's backwards, 3/7, in fact does give you 1.8. Exactly. So they have just goofed. Yeah, they've goofed. There's no other way to put it. They're off by a factor of 10 on their correct answer. And I've worked this 4 or 5 times now, so they've just messed up.